Assalamualaikum. We are from Group 4. We will present to you about thermal expansion. Before we start, I will introduce to you to our group member. First, we have Nur Asiki binti Yusfandi, matrix number AA222117. Then we have Nurul Shafiqah binti Muhammad Shah, matrix number AA221378. Then we have Nur Sabrina Dayana binti Kamal, matrix number AA221108. And lastly, I'm the last member of the group. My name is Fadi Sakira Batina Abdan, matrix number AA222051.
So, learning outcome for this topic, which is thermal expansion. First is understand the meaning of thermal expansion. Second, understanding and calculate the linear expansion. Understanding and calculate the area expansion and volume expansion. And the last one is understand and calculate the stress expansion.
Assalamualaikum, my name is Nur Shafiqah binti Muhammad Shah. This slide, I want to present about the thermal expansions. Okay, thermal expansion. What is thermal expansions? Thermal expansion is increase or decrease of the size, length, area or volume of a body due to a change in temperature. The expansion occurs in any substance, such as solid, liquid, or gas, by virtue of the increase in its temperature is termed thermal expansion. Okay, you can see the picture on this slide. It shows about the temperature change when the water is heated. Okay, go to the next slide. Okay, you can see the picture on the left show the particle before heating and after cooling, and the other side show the particle after heating or before cooling. Application of thermal expansion. There are many applications of thermal expansion, some of which are as follows. First, thermal expansion used in thermometer to measure the temperature. Second, thermal expansion is used for the removal of tight lid. Third, rubber spacers are required for window with metal frame.
Now for the pop quiz for this part. First, the first question is what are the meanings of thermal expansions? And second, what kind of substance can expansions cause? And the last one is what the thing that are increased if the substance are having thermal expansions. So the answer are, the first one is the increase of the or decrease of the size of the body due to a change of the temperature. The second answer is solid, gases and liquid. And the last one is, the answer is temperature.
Okay, next, this slide, I want to present about linear expansion. Linear expansion is length. First, a higher temperature means that the molecules are moving faster on average. Second, when a material is heated, the molecule inside that material start moving faster, and as a result, they take up more space. Third, they tend to move into areas that were previously empty. This increases the size of the object. You can see the picture that you can imagine it. The formula to use linear expansion is total length equal to alpha multiply LO multiply total temperature. The coefficient of linear expansions alpha depends on the material. Okay, look at the other side. This is the example for alpha or average coefficient of linear expansions. Okay. Okay, total temperature equal Tf minus Ti, where Ti is the initial temperature and Tf is the final temperature. Example 1 of linear expansions questions. A steel of 40 cm long at 20 Celsius, the coefficient of linear expansion for steel is 12 multiplied 10 power of 6. The increase in length and the final when it at 17. Okay, first highlight the important information. Step first, find the change in temperature. So 17 Celsius minus 20 Celsius equal to 15 Celsius. The original length L1 is 40 cm. Coefficients of linear expansion for steel equal to 12 multiplied 10 power of negative 6. So that's refer the table give or based on questions. So what the question want? The change in length and the final length. Step 2, find the change in length. Okay, use the formula. Change in length equal to alpha multiply L1. L1 is original length multiply change in temperature. Okay, so calculate that and the answer is 0.024 cm. Next, step 3, find the final length L2. So the formula is L2 final length equal to L1 is original length plus change in length. So 40 cm plus 0.024 cm equal to 40.024 cm.
Next, for area expansion, it is relates to a change in temperature to a change in the area dimensions of the material. The fractional change in the area per degree of temperature change is what the stems refers to. And N+1 is an area expansion is two-dimensional material expansions that the temperature of the thing determines how much it expands. So based on the picture that have been given in this video, we can create a formula for this area expansion by first for the equation is A equal to A naught plus the change of A, which is A equal to area, and solve it to become A equal to 2 alpha multiplied by A and multiplied by the change in temperature. So 2 alpha we can transform it into 2 beta, which is beta equal to 2 alpha, and the last formula for this area expansion that we're going to get from this equation is change of A equal to beta multiplied by area naught multiplied by change in temperature. But for the last part, for the area expansion, we're going to have a quick questions for this part, which is the questions are at 20 Celsius, the length of a sheet of steel is 50 centimeter and the width is 30 centimeter. If the coefficient of linear expansion for steel is 10 to the power of negative 5 Celsius, determine the change in area and the final area at 60 Celsius. So from the questions, we know that the initial temperature T1 equal to 20 Celsius and the final temperature is T2 equal to 60 Celsius. So what we have to find first is change in temperature, which is 60 Celsius minus 20 Celsius equal to 40 Celsius. And then next one, we have to find the initial area by multiplying length and width of the sheet of steel that have been given in the question, which is 50 centimeter multiplied by 30 centimeter, and the answer is 1500 centimeter square. So the next one, in the question, it have been given the coefficients of linear expansion for steel, which is alpha equal to 10 to the power of negative 5 Celsius. So to find the beta of the formula, which is we have to multiply it by 2, and the answer are 2 multiplied by 10 to the power of negative 5 Celsius. So the next one, what we want to find here is the change in area. So we have to use the formula from the area expansion, which is change of A equal to beta multiplied by initial area multiplied by change in temperature. So from the data that we get here is just enter the value to the equation, and it's going to be change of area equal to 2 multiplied by 10 to the power of negative 5 Celsius multiplied by 1500 centimeter square and multiplied by 40 Celsius, and the answer is 1.2 centimeter square. So the next one that we have to find is the final area for these questions. So what we have to do is A final area equal to initial A plus the change of A, which is 1500 centimeter square plus 1.2 centimeter square, and the answer is 1501.2 centimeter square. So that are the final answer of this question.
Hi, Assalamualaikum warahmatullahi wabarakatuh. I am Rashid Ibn Isfandi, so I will explain about the volume expansions. So, volume expansion totally happen to the volume type of things only, for example, like water. And the definition of volume expansion is the change of the volume due to the different temperature. So, the formula for the volume expansion is gamma times with the change in the volume and the change in the temperature. So for information, water is also one of the volume type. So water totally one of the things that can be expressed when it is boiling. Questions. So the questions one is at 30 degrees Celsius, the volume of an aluminum sphere is 30 cubic. The coefficient of linear expansion is 24 times with 10 power of negative 6. Okay, the final volume 30.5 cm3. What is the final temperature? So we need to find the final temperature. So as you guys know, gamma equal to 3 alpha. So we need to times the linear expansions with the 3, and we got the answer, which is 72 times with 10 power of negative 6. So we need to know the change in the volume, which is we just need to minus it. So the answer is 0.5, and the information that we got from the questions, and just now we need to just fill it in the formula. So we got the answer is 260 degrees Celsius.
Liquid expansion. Liquid expansion refers to the phenomenon where the volume of a liquid substance increases at its temperature. Most liquids like water, oil, and alcohol have characteristic property of expanding when heated and contracting when cooled. This behavior is a result of the increased kinetic energy of the liquid molecules as the temperature rises, causing them to move more vigorously and spread out. This is the Q&A for liquid expansion. The first question, what is the definition of liquid expansion? The answer is the volume of the liquid substance increases as its temperature rises. Second, What is the result of the liquid expansion? The answer is the kinetic energy of the liquid molecules increases as the temperature rises. The last question is, what is the characteristic property of a liquid? The characteristic property of a liquid is expanding when heated and contracting when cooled.
So for the conclusion, finally thermal expansion refers to the tendency of material to expand or contract in response to temperature variations. More substances expand when heated and contract when cooled. The phenomenon happens as a result of the higher kinetic energy of the particles in the material, which result in a greater average distance between them and an increase in volume. I think that's all for me. Thank you.